Hey guys, here's a video on some of the exponent rules we did today. The first thing I want to talk about is negative exponents. And the biggest thing that you need to know is that we can never have negative exponents. So whenever we have one, we have to make it into a positive exponent. So like I said here, they're illegal, and now we have to make them legal. So that's saying that they're negative and we want to make them positive. So right now, my first example is I have x to the negative third, which when we did it today, we had those numbers like 5 to the third is 125, 5 to the negative third is 1 over 125. So what we really end up doing is take this number and put it in the other part of the fraction. So right now you have this number over 1, and you want to put this down on the bottom. And if you switch the place from the top to the bottom or the bottom to the top, it'll make your exponent positive. So in the end, we get 1 over x to the third. If you imagine that as a 5, it kind of makes sense to you, because 5 to the third is 125. 1 over 5 to the third is 1 over 125, which is the same as 5 to the negative third. That's something we did in class. So basically what I'm saying is, switch where it's located in the problem. You'll see another example in the next slide. We have 1 over y to the negative 7. So the denominator now is a negative exponent. We need to take that and throw it up to the top. So by putting it on the top, it becomes positive, and you have y to the 7. And the denominator now is just 1, so you don't really need it. You can just say y to the 7. Don't think that necessarily you're flipping it, because that's not the case. Sometimes you're only moving pieces. You're only going to move one of the variables sometimes. We'll get to examples like that. Example 3, y to the 4th over y to the 8th. Well, these are both positive. But when you divide, when you have the same base, you would subtract the exponents. Alright? Remember we did this in class. Same base, division, subtract the exponents. So you have y to the, let's see, 4 minus 8 is negative 4. So you have y to the negative 4th power. And that's not good. That's no good now because it's a negative exponent. So we want to throw it in the bottom, and it becomes 1 over y to the 4th. Right? We take that from being over 1 and put it to the bottom. So simply moving it from the top to the bottom or the bottom to the top will make it positive. Let's look at this problem. This has a lot of different parts to it. So let's first do the quotient rule. So do the quotient rule with the x's. This is where it's going to start to get a little trickier. This is where we're going to start to apply a lot of the rules into the same problem. We're going to do the variables first because we want to think in exponents, and then we want to think in numbers after. So we have x over x to the 5th. So what that's saying is 1 minus 5, right, since we're subtracting the exponents. Everything that doesn't have an exponent has an implied 1 on it. So that becomes x to the negative 4th. We want to put everything up on the top in the numerator. Everything that we simplify with exponents, we want to put on the top. So we have y to the 6th over y to the 3rd next. So 6 minus 3 is 3, and that's y to the 3rd. That's going to go back on the top. Now we just want to deal with the numbers. So once we've done all of the variable stuff, we can do the numbers next. 4 over 8, I mean, there's no exponents, there's something to combine here, they don't have the same base, but when you think about 4 over 8, you're like, oh, that's the same as a half, right? There's 2 4s and 8, so 4 is a half of 8, so we can reduce that to 1 over 2. And now here's what I'm talking about, just moving negative exponents. So you identify the problem, that's x to the negative 4th, and you take that and you put it into the denominator. So you don't move the y, you don't move the 1, you don't move the 2, you only move the problem, and that's the negative exponent. So in the end, our answer should be, you don't need to rewrite the 1, it's just implied, y to the 3rd over 2x to the 4th. All I did was move the negative exponent. Everything that was a positive exponent or didn't have a designed exponent on it, like that's 2 to the 1st or 1 to the 1st, which you didn't need to write, it didn't move. Okay? Everything else stayed except for the negative exponent. So that's sort of an intro into when it gets harder. Now I'm going to do 2 problems that are probably as difficult as you'll see. And if we can handle those, we can handle anything. Alright, so this is number 5. We got a division happening in here, but we have an exponent on the outside. And what we know from today is that when you have anything, quotient on the inside or a product on the inside raised to a power on the outside of parentheses, you need to multiply everything on the inside by that exponent. So that includes the 2, the x, the y, the z, the 3, the x, the y, and the z. So this is going to get real complicated real fast. But if you keep everything in order and you go rule by rule, you'll be fine. 2 to the negative second. Right, that's 2 to the first. 1 times negative 2 is negative 2. X to the first, right? Anything that doesn't have any exponent is an implied 1. That's x to the negative second. Y to the 8th. Negative 2 times 4 is y to the negative 8. So y to the 4th times negative 2 is y to the negative 8. Z to the negative 6. Negative 6 times negative 2 is z to the 12th. On the bottom, 3 is to the first power, so that's 3 to the negative second. Sometimes your numbers are going to have exponents too. You just do the same process. X to the negative 4th. Negative 4 times negative 2 is x to the 8th. Y to the negative 2. 1 times negative 2 is negative 2. Z to the second times negative 2 is z to the negative 4th. Bad, right? I mean, it's a lot of work, but in the end, it wasn't all that difficult. I mean, it's a lot, but it's not that difficult. It's just a simple multiplication. From here, parentheses are gone, nothing's on the outside, we can use the quotient rule. So let's do our variables first. X to the negative second, x to the 8th. So that's negative 2 minus 8, which is negative 10. So we have on the top here, x to the negative 10. Y to the negative 8 minus negative 2. So that becomes a plus, and that's to the negative 6. Y to the negative 6. Then we have z to the 12 minus negative 4, which ends up being addition, so that's z to the 16th. So right now we see two problems. We have negative exponent here, negative exponent here. The numbers, do they have the same base? No, so we can't combine them. All we can do is make sure our exponents get positive. 2 to the negative second needs to go move to the bottom to become positive, right? That becomes 2 to the second. 3 to the negative second needs to move to the top to become positive. So I'll give you a second to kind of take all that in. All I did was the quotient rule with all 3 variables. Negative 2 minus 8 for the x's, negative 8 plus 2 because it's a negative on the bottom, minus minus, or we're subtracting when we're dividing. 12 minus negative 4 is plus, so it's 16 for z. And for these numbers, since I didn't have anything to quotient rule them with, since there's no quotient rule for the numbers, I just reversed where they were to make their exponents positive. Now we're almost ready to completely simplify this. So let's just do what we know. 3 to the second is 9. That's 3 times 3. 2 to the second is 4. It's 2 times 2. Z to the 16 is a positive exponent. It stays where it is. The other 2 are negatives and need to go move to the bottom. X to the 10th, y to the 6th. And you're done. Because all you have now, one of each variable, the numbers are simple, and all positive exponents. And that's when you know you're done. When you have one of each number, your numbers are as simple as possible, and your exponents are all positive. That is how you know you have your simplified final answer. I know it appears overwhelming, but this is just about as difficult as it'll get. I have one more problem that is one step further, and that's it. If you can do a problem like this, you are set, because nothing is going to be as difficult as this. Alright, problem 6. This is the worst. The reason it's the worst, we had the same thing as the last time, but now we have something on the outside, and you'll see it's not that bad. So again, distribute your exponent to everything on the inside. Multiply it by every exponent. So you have 4xy cubed left over. negative 8 to the 4th, x to the 8th, y to the negative 12, z, 4 times 0 is still 0, 4 to the 4th, x to the negative 12, and y to the 32nd. All I did there was take my exponent from the outside and multiply by everything on the inside. Something we learned today about quotients to a power and powers to a power. From here, we can use the quotient rule for what's inside the parentheses. So let's do variables first. We have 8 minus negative 12, so it becomes a plus, and that's 20. So that's x to the 20th. That's going to be on the top. So let's rewrite this first part. 4xy cubed, and then inside parentheses we'll say x to the 20th, right? So we combine these, then we say y to the negative 12. So that's negative 12 minus 32, which is negative 44. So we have y to the negative 44. And z to the 0. What's anything to the 0 power? 1. So this is going to equal 1, and we don't need it anymore. Remember, 1 doesn't do anything when we're multiplying. It just is the multiplicative identity. It keeps everything the same. So now we have numbers. Negative 8 to the 4th. There's non-negative exponent, so it can stay where it is. And that's something you have to remember, is that just because the number is negative does not mean the exponent's negative. Don't move it unless this is negative. This is fine, this is not. And 4 to the 4th will go on the bottom. So now we're dealing with two things being multiplied. Product rule, right? Multiply this by this, combine their like terms, so that's 4 times negative 8, 4 times negative 8 to the 4th, x to the 1st times x to the 20th is x to the 21st, remember the product rule. Y to the 3rd, y to the negative 44th is y to the negative 41st. And on the bottom, we're still left with the 4 to the 4th power. Now, when you get to this point and you have numbers like this, like negative 8 to the 4th, you can simplify that. And 4 to the 4th, you can simplify that as well. So, I'm going to do that, just to make my life easier now. Notice there's no parenthesis around the negative 8, so you don't use a parenthesis. And this becomes negative 4,096. Multiply that by 4 on the top, because remember we treat numbers like numbers, so we can kind of multiply those two together. 4 to the 4th on the bottom is 256. X to the 21 stays on the top because all the exponents are positive, and y to the 41st moves to the bottom because you got a negative exponent. From there, you can simplify your numbers. If I haven't lost you yet, congratulations, you're doing awesome. And I'm telling you right now, this is the simplest, or this is the most difficult problem you'll ever see. These two numbers simplify to be 64. So you get negative 64 x to the 21 over y to the 41. This is like an honors level problem, and if you can do it, you're doing great. I just wanted to show you that every single rule that we use can be used in a different way at different points in the problem, and that if you use them legally, come out with your right final answer. I expect you can do a problem like this, number 5. A problem like number 6 could be quite difficult, but at the same time, if you do your rules legally, you have a shot to do it. Thanks for working so hard.